One of the last topics that we're going to look at here with polynomials is dividing polynomials. And what you're going to notice in math is that if you can do something in math, there's usually a way to undo that as well. So if you can add something and you really didn't want to do that, you can undo it by subtracting. If you multiplied but you really didn't want to, you can undo that by dividing. So when I say we can multiply polynomials, we can multiply monomials, well, if you can multiply, you can probably divide. That's just the way math is. Math is nice like that. In life, that's not how things work. When you do stuff in life, you really can't undo it most of the time. But in math, there's always a way to go back. In most instances, there's a way to go back to where you were originally. So here I have a division. I have this mess of variables and numbers, and I want to say, how do I actually divide this monomial into this group of stuff up here? And what I'm going to do is, instead of trying to do it all at the same time, I'm just going to break this problem into two separate problems and worry about it from there. So I'm going to take the first part of this binomial that's on top, and I'm going to write it out as a fraction. And then I see there's kind of this negative sign here, so I've got to figure out what I'm going to do with it. Do I want to put a minus in between like this and have it 15xy squared? Or do I want to attach that as a negative to this top number and make this a plus? Doesn't matter which way you do it. I'm just going to leave it like this for now. If I had included this as a negative, then I'd get a negative when I divided, and then it would end up moving to the middle anyway. So I'm going to split this into two problems, and now I'm going to simplify each one separately, starting with division. 6 divided by 6 is 1. So I just have the number 1. I don't even need to write it because it's multiplication. I know that when I multiply 1 times a number, it's just going to be the number. So I'm putting the 1 there just to show that I divided these. But then something different happens when I look at the division here. If I'm conceptually trying to figure out what x to the 5th is, I would have to write x as a factor 5 times. This is what x to the 5th looks like. If I were dividing by x, I would see that one of those will simplify to 1. Any number divided by itself is 1. So I'm crossing those out. That's going to leave me with x to the 4th. Now, the trick is, when I was multiplying, I just added the exponents. If I look at my 5 and my 1, I can see they subtract 4. So I've got, really, if I want to try get a shortcut here, I divided 6 by 6, but then I did 5 minus 1 because they were both exponents. There it is. If I had y to the 3rd divided by y, I could do the same thing, list out y to the 3rd, list out y to the 1st on the bottom. I can see that any number divided by itself is 1, and I'm left with y squared. But the shortcut to that is to just look at it and say, well, when I'm dividing, I subtract my exponents, and I could do 3 minus 1 is 2. So I'd have a quick way to get to the answer. Unfortunately, when I look at this next one, 15 divided by 6 is a decimal. And I don't want to really use decimals here. I want to keep fractions. I'm going to keep a simplified fraction. So 15 over 6 simplifies down. I can divide those both by 3. This simplifies down to 5 divided by 2. 5 halves. And then I can look at my x's. X divided by x is a number divided by itself, which is always 1. It doesn't matter what that number is. Any number divided by itself is 1, with the exception of 0. I can't tell you what 0 divided by 0 is. Neither can Harvard or Yale professors. So we're just going to say x is a non-zero number in this case so that we can make it work. It crosses out completely. I don't have anything left for x. But with my y, I do have something left. Y times y on top, y on bottom. Anything over itself is 1, but I still have a y remaining, so I'm just going to set that y there. we now have a completed answer because these are not the same as this, so I can't combine them any further. With addition and subtraction, I need the same exponents raised to the same power to combine them, and these are not the same, so I'm done. Even if this was a y squared, I still couldn't combine these because there's an x here and not here. So with addition and subtraction, it was very specific. Everything has to be the same variable and exponent-wise in order to add or subtract. But when I'm multiplying and dividing, exponents change, so I can do whatever I wish.